Hello, welcome to my final project, the minimum spending tree visualization. The goal of this project is to provide an interactive learning tool to help us visualize how minimum spending trees are constructed. This program uses two classic algorithms, prims and Kruskals. First, let's take a look at the interface. It was built using SimpleFast Multimedia Library. The UI is divided into two parts, the control menu on the left and the visualization area on the right. For the construction of MST, we must generate a graph first. On the control menu, we have a settings section to do that. The user can input a number between 2 to 100,000 in the box, and that's the number of nodes in our graph. Now we use the defaulted value, 200, and click the Generate Graph button. We can see that we create a connected, undirected graph with 200 nodes. The weight of the edges is the distance between two nodes. Now let's run the Kruskal algorithm animation. We can also control the flow using the slider in the animation control section to speed it up or to slow it down. You can see the edges turning yellow when they are being considered by the algorithm, and then turn blue once they are accepted. And this button allows us to pause the animation to analyze a specific step. Next, let's look at Prim's algorithms. Unlike the Kruskal, which connects edges all over the graph, Prims grows the MST from the defaulted node with ID 0 and expands the tree. For quick analysis, we have the instant button. This runs the algorithm in the background and immediately gives the final MST. We can say if the weights of every edges are unique, we can also have a unique tree. In the statistics section, we can capture the execution time in microseconds. This allows us to compare the performance on the same dataset. We can say, for this graph, Prims is faster than Kruskal. We can also have the total weight of the MST. And the edge count of our MST will always be n minus 1. Because of a limiting showing area, the program can visualize at most 1,000 nodes graph, for graphs with nodes between 1,000 and 100,000. Let's see an example of graph with 10,000 nodes. After running the algorithm, instead of drawing a messy hellball of lines, the program presents the MST edges in table. Only a sample of 100 edges are shown here, and their weights are also listed. This concludes my MST visualization project. Thank you for watching.